So basically, there were two types of compounds, which I told you that you either have a very large difference in electronegativity, which makes the compound ionic, that the difference in electronegativity is so large that that one of the electron completely gains the electron compared from the other one. The more electronegative one gains the electron, and the
Sir?
less. Haji.
सर आपकी वॉइस लैग कर रही है थोड़ी सी.
अभी ठीक है?
Yes, sir.
अच्छा, तो हमने डिस्कस किया था, we discussed that if you have a huge difference in electronegativity, that is, one element belongs to the left side of the periodic table and the other one belongs to the right side of the periodic table, then one of the element would gain electrons, the other one would lose electrons. Okay? And that was ionic compounds. But then we talked about covalent compounds. I told you that a covalent compound has sharing of electrons because both atoms have the same electronegativity, or similar electronegativity, which makes it, which is why they end up sharing electrons, because the electrons, they kind of get stuck in the middle because both atoms are trying to pull the electrons with kind of an equal force. So in this case, what happens is that you have a simple molecular structure, which means that you've got these small molecules and another small molecule, and there would be very weak intermolecular forces between them. And we're going to talk about those intermolecular forces. Covalent molecule, and remember, intermolecular forces, they only exist in covalent molecules. Make sure you get this confusion. I mean, a lot of people make this mistake. Intermolecular forces, they never exist in giant structures, apart from graphite. They only exist in simple covalent molecules. Like if you have an ionic compound is going to be, it's going to be a giant ionic lattice. It's going to be a series of positive and negative ions all attracting each other. So it's going to be this big giant structure, a big crystal that's going to be formed. There's not going to be any intermolecular forces. There's only going to be ionic bonds in an ionic lattice. But in covalent molecules, the molecules are really tiny, and those tiny molecules will not be attracting each other because they're not going to have any charges. So there's just going to be very weak intermolecular forces. So remember, the word intermolecular forces only applies to covalent molecules and should not be used anywhere else. That's the first thing. Now,
Sir?
Haji.
सर आपने कहा था giant structures के नहीं होगा, मतलब आपने फिर भी कहा था except कोई आपने बताया था कोई.
Graphite. Okay, one is the giant ionic lattice. I'll just go through all of them. Okay, so one of them is the giant ionic lattice. So ionic compounds, where's the image? Achha, so there are three types of giant structures. One of them is the ionic lattice. It only has ionic bonds, just positive and negative ions, all attracting each other. So there's no intermolecular forces. I mean, there is no intermolecular force. There's just ionic bonds. Okay, ye pehla clear hai? Is this clear?
Yes, sir.
The second type of bonding is the giant covalent, which we haven't done yet, but the giant covalent structures like diamond, okay? They, like diamond or silica, okay? They are giant structures. What happens to them is that giant structures, I mean, let's take a look at this one. So giant structures, they just have covalent bonds over and over again. It's just a continuation of every atom is covalently bonded to all other atoms. So there's just covalent bonds, nothing. So if you have a diamond, the diamond only has covalent bonds. There is no intermolecular force. DK, is that clear?
Sir?
हाँ.
तो डायमंड के अंदर सिर्फ like intermolecular forces नहीं होगा आप कह रहे हैं?
हाँ, नहीं होंगे ना. There's no intermolecular force. Like, where's the intermolecular force? Every atom is bonded to every other atom. So there's just covalent bonds. All of them are covalent bonds. So intermolecular forces exist between one molecule and another molecule. Yahan pe there is no molecule. There's just this one big structure. Is that clear?
So फिर
Yes, sir.
graphite कैसे exist करती है?
हाँ, graphite में exist करती है because intermolecular forces will exist if you have two separate things. ठीक है? For example, over here, I mean, like, जैसा वो पहले शो किया था, if you have two separate small molecules. Now in graphite you have graphite is the only there are other giant structures as well that have intermolecular forces. So if I show you the graphite structure, so in the graphite structure you will have intermolecular forces, and the reason for that is that one sheet of graphite and the other sheet of graphite, they're not connected together. They don't have a bond. They just have weak intermolecular forces. Just like they've written van der Waals forces. Is that clear? So like if you have a graphite sheet, you have another graphite sheet, they're not bonded together. So this sheet will attract, so intermolecular forces will exist in two separate things. Is that clear? And the same thing would happen in giant metallic lattices. That is also just metallic bonding, no intermolecular force. Like if you have a giant metallic lattice, it would kind of look like this. It's going to be,
सर
हाँ जी,
सर आपने रीजन क्या बताई थी ग्रेफाइट की कि क्या वजह है उसकी?
क्योंकि उसमें दो अलग अलग चीजें हैं ना. You have a sheet of graphite, you've got another sheet of graphite, and they're not connected together. ठीक है?
ओके सर.
अच्छा, so metallic bonds, like if you have a piece of like you have a piece of iron or steel, it will only have metallic bonds. That's about it. Delocalized electrons, metal ions in a sea of delocalized electrons. There's not going to be any intermolecular forces. This is one interconnected structure. That's it. So it's not like two different things and having some weak intermolecular forces between them. So is that clear that giant structures, they don't have giant ionic, giant covalent, and giant metallic. They don't have intermolecular forces with the exception of some giant structures like giant covalent structures like graphite. Or we'll do other ones as well, like nano, these fullerenes and nanotubes. So we'll discuss that later, okay? But remember,
तो सर
हाँ जी,
सर ये डायरेक्टली ये डिपेंड करेगा उसके इलेक्ट्रॉन के अरेंजमेंट पे ना,
क्या चीज?
इंटरमोलिकुलर फोर्सेस.
मतलब अभी तो वो स्ट्रक्चर्स बताया ना कि वो स्ट्रक्चर्स तो एक ही स्ट्रक्चर है, दैट्स वन बिग स्ट्रक्चर, राइट? तो मैंने बताया कि intermolecular forces will exist between small, I mean they would usually exist between small covalent molecules attracting other small covalent molecules. ठीक है? So they would exist between them most of the time.
तो मतलब जाइंट में बहुत कम एग्जिस्ट करता है, जैसे आपने एक्सेप्शन बताई ग्रेफाइट.
हाँ, मतलब दो totally separate चीजें होंगी ना, then there's going to be intermolecular forces. Like intermolecular word means between two things, right? So if there are two completely separate things, then there would be some intermolecular forces between them. Is that clear? Like if you take a metallic any metal piece, that is just one interconnected thing. It's not going to have intermolecular forces. ठीक है? Is the idea clear?
यस सर, जैसे NaCl एक कंपाउंड और दूसरा NaCl कंपाउंड, उनके दरमियान भी नहीं हो सकती ना?
मतलब उनके बीच में तो होगी, लेकिन when you talk about NaCl, you talk about this one big crystal, right? And so when you think of NaCl, you're basically talking about one NaCl crystal. I mean, obviously one NaCl crystal and another NaCl crystal, they're going to have intermolecular forces, but you don't think about NaCl in that way. Like if you talk about NaCl, you take a salt particle. So you usually think, well, if I just write NaCl crystal, so this is if it's for some reason that. So when you think of the NaCl crystal, can you hear me?
Yes, sir.
Just 1 second. I know. When you think of NaCl crystal, you don't think of it in that way, that it's one NaCl crystal and another NaCl crystal. It's basically, I'm talking about this NaCl crystal. Will it have intermolecular forces? There's not going to be any intermolecular forces existing inside this structure. Okay, is that idea clear?
Yes, sir.
Acha, so intermolecular forces would be about simple, small covalent molecules. I mean, that's the first thing that we'll discuss. And there are three types of intermolecular forces. The first type is, let's start with permanent dipoles. We've got permanent dipoles. So permanent dipoles are going to be present. It depends on two things. First thing, what is a permanent dipole? I'm going to explain that later, but a permanent dipole depends on two things. One of them is that there should be a difference in electronegativity between the atoms in the molecule. And the second thing about that is that there should be, it's the shape of the molecule. And what you state is that the dipoles don't cancel out. So let's discuss this. So remember, permanent dipoles, they depend on two things. There should be a difference in electronegativity of the molecule. So for example, if I have an HCl molecule and I have another HCl molecule, the HCl molecule has a covalent bond with one electron being shared. The other HCl molecule also has a covalent bond with one electron being shared. Now, the thing in this case is that if I have an HCl molecule, the electrons that are being shared, which atom is more electronegative? Is H electronegative or Cl electronegative?
Cl.
So the electrons, they're not going to be evenly distributed. They won't be exactly in the center. The electrons would be closer to one of the atoms. So the Cl over here will have a slight negative charge, just very slightly. So the electrons will not be exactly in the middle. The difference in electronegativity is not that huge, but still Cl is more electronegative. So the electrons over here would be closer to Cl, and the H will get a slight positive charge. And the same applies to the other HCl molecule. So they're all going to have a permanent dipole. The reason you use the word
Sir,
permanent, yes. हाँ बोलो जी. So you've got an HCl molecule and they're going to have dipoles, and it's going to be a permanent dipole. The electrons would always be closer to, Cl. And because there's a dipole, the first thing is, what is the definition of what a dipole is? So they're going to ask you about this. A dipole is, it's the unequal distribution. Remember the definition. It's the unequal distribution of electrons in a bond due to a difference in electronegativity due to a difference in electronegativity resulting in slight positive and slight negative charges. Slight negative charges on the atom. And dipole, a polar bond, they all kind of have the same definition. Okay, so they're going to ask you what a dipole is. So this is what a dipole is. Dipole means two poles. So this one has two poles, like you have a north and a south pole. Over here, you have got a positive side, you've got a negative side, but it's only slightly positive. This is only slightly negative. And now you have a polar molecule. This is known as a polar molecule. The two molecules are going to attract each other weakly though. The slight negative part will attract the slight positive part of the of the other molecule, and there's going to be this weak intermolecular force that is going to be known as the permanent dipole interaction, or simply just use, so it's a permanent dipole interaction, or you can write it 2 times, permanent dipole interaction. Is this clear? The
Sir?
first, हाँ जी.
सर ये जो आपने हाइड्रोजन हाइड्रोजन और क्लोरीन जो है इनके बीच में तो कोई लाइक वो नहीं होगी ना कोई इंटरमोलिकुलर फोर्सेस तो नहीं हो सकती ना लाइक ऑन
नहीं, इन दोनों के बीच में तो कोवलेंट बॉन्ड है ना. Intermolecular forces between one molecule and the other molecule. ठीक है, is that clear?
ओके सर तो इंडिविजुअली नहीं लाइक कलेक्टिवली होगा.
हाँ, मतलब intermolecular forces between one molecule and the other molecule. Inside the molecule there's a covalent bond. ठीक है.
अच्छा, परमानेंट डाइपोल मतलब वही है ना कि मतलब पार्शियल चार्ज आ जाए दोनों पे.
हाँ, and why do you get a partial charge? Because there's a difference in electron. And
सर
this,
तब क्या होगा?
हाँ,
कोई डिफरेंस नहीं हो. सर जब
क्या
कोई डिफरेंस नहीं हो फिर क्या बोलेंगे उसे?
उसका उस पे आते हैं हम. ठीक है, उस पे हम आते हैं.
सर
हाँ
सर ये इसे पार्शियल कहते हैं जो आपने बनाया.
हाँ, पार्शियल या स्लाइड. पार्शियल वैसे कहते हैं. करेक्ट वर्ड इज पार्शियल नेगेटिव, पार्शियल पॉजिटिव. ठीक है, मतलब you just write delta positive, delta negative. अच्छा, anyway, so when will you not get a dipole? You're not going to get a dipole if there is no difference in electronegativity. So for example, you've got a fluorine molecule. So the fluorine molecule, the electrons would be exactly in the middle. Like the force of attraction, both atoms will try to attract the electrons with equal force. And the dipoles are going to get cancelled out. So this is called dipoles getting cancelled out. I did use the word that the dipole got cancelled out. So we're going to talk about that a little bit. That means the electrons would stay in the middle, because think of this as a tug of war, one atom trying to pull the electron on towards the right, the other one trying to pull the electron towards the left, but they are pulling it with equal force, which means the electrons would stay exactly in the middle, which is why this molecule over here is not going to get a permanent dipole. There's not going to be any side that is going to be permanently negative or that's going to be permanently positive. Is that clear?
Yes, sir.
Okay, so the first thing is, so in this case, the dipoles cancel out. The two forces, they cancel out. Now, the shape of the molecule is also very important, because I did write 2 points that the permanent dipoles, they also depend on the shape of a molecule. So we did do the shape of the molecules. Now, for example, let's think of sulfur dioxide. So if you think of sulfur dioxide has 2 oxygens. It's bonded to 2 oxygens, but it's got a lone pair as well. So it's bonded to 2 oxygens. But can make it, that's fine. So sulfur dioxide is bonded to 2 oxygens. And the shape of the molecule is going to be fan shaped, except that one side of the fan, there's nothing attached. There are 3 pairs of electrons, 1 lone pair, 2 bond pairs. So the molecule is going to have a bent shape, and the angle would be approximately 120 degrees, right? ये निकल किया था. So in this case, which atom is more electronegative? Is it sulfur or is it oxygen? Who's more electronegative?
Oxygen.
Okay, oxygen is more towards the corner of the periodic table. Okay, right top corner. वो तो clear है ना? We did do that. If the screen is the periodic table, the right corner, the top right corner, that's the elements that those are more electronegative. Now in this case, oxygen is going to pull the electron very strongly. Now think of it in terms of physics, like vectors. So both oxygens are trying to pull the electrons downwards. So what will happen to the electrons? The bottom, the dipoles are not going to get cancelled out. Think of it that there's a thing over here, and there are 2 people trying to pull it. One is pulling it in this direction, the other one is pulling it this direction. So the electrons will get pulled downwards. And this oxygen will over here get a negative charge. This oxygen over here will also get a slight negative charge, and the sulfur at the top will have a slight positive polarity, because the oxygens are trying to pull the electrons in one direction. They're trying to pull the electrons downwards. So the dipoles are not canceling out, and this molecule is going to have a dipole. Is that clear? And
Yes, sir.
okay, and if you have two molecules, the two molecules, like if there's another molecule, that will also have a permanent dipole, and the two molecules will kind of attract each other. So for example, the positive part of one molecule will get attracted to the negative part of the other molecule. So the dipoles will attract each other. The negative side of one molecule will attract the positive. So there's a permanent dipole attraction or interaction. Now, the other thing is, let's take the same example of sulfur, but this time it's sulfur trioxide. Now, in sulfur trioxide, it's got a fan-shaped molecule. It's a fan-shaped molecule. So,
सर
Haji.
सर आपने कहा है कि जो एक का स्लाइड नेगेटिव होगा दूसरे का स्लाइड पॉजिटिव के साथ अट्रैक्ट होगा.
हाँ, तो नेगेटिव और पॉजिटिव ही अट्रैक्ट होते हैं ना. ठीक है, मतलब डाइपोल इंटरेक्शन जब शो करनी है ना, they're going to ask you to draw this. Like if they ask you to draw HCl, so you're going to draw the negative part of Cl is getting attracted to the positive part of the H on the other molecule. ठीक है. So let's talk about sulfur trioxide now. Now in sulfur trioxide, you've got 3 oxygens. So the molecule is going to have, there's no lone pairs. Okay? It's group 6. So 2 electrons shared here, 2 electrons shared over here, 2 electrons shared over here. So in this case, there is no lone pair. So all the oxygens are trying to pull the electrons in 3 different directions. They're trying to pull the electrons in 3 different directions. Now imagine, in terms of physics, that the force of attractions are going to get cancelled out. All 3 oxygens are trying to fight over electrons. One is trying to pull electrons in this direction. The other one is trying to pull the electrons in the upward direction. One of them is trying to pull the electrons over here. So imagine like there are 3 people fighting over the stuff. So the electrons would stay exactly wherever they are, because the 3 forces are acting against each other, and the force of attraction is going to get cancelled out now. So the dipoles in this case are going to get cancelled out. The electrons are not going anywhere, because the 3 forces of attraction, just like a vector diagram, they will get cancelled out. Okay, is this clear?
सर पिछले वाले में इलेक्ट्रॉन्स जो
Yes,
थे
sir.
मतलब लोन पेयर्स की वजह से हमारा वो डाइपोल बन गया था.
नहीं, लोन पेयर्स को तो छोड़ो, वो था कि शेप की वजह से ना. Both oxygens were trying to pull the electrons in the downward direction, right? तो खुद सोचो ना कि 2 बंदे वो एक चीज को नीचे की तरफ खींच रहे हैं, तो क्या होगा? वो चीज नीचे ही आ जाएगी ना. मैं खुद सोचो कि लेट्स से ये टेबल पड़ा हुआ है, and there's one person pulling that table over here and the other person is pulling the table over here. The table will drag in the downward direction, right? But now imagine the table is in the middle and there are 3 people. One is trying to pull the table in this direction, one is over here, the other one is dragging it upwards. So the table would stay exactly in the middle. So think of
बेसिकली कांसेप्ट यही है कि मतलब अगर वो मूव नहीं करे तो उस पे कोई चार्ज नहीं होगा पार्शियल, अगर वो मूव करे तो फिर पार्शियल.
हाँ, कि वो cancel out हो जाएगा ना, क्योंकि the 3 forces of attraction are going to get cancelled out. So the electrons would stay evenly distributed. वो एक साइड पे नहीं जाएंगे, वो इधर नहीं चले जाएंगे, वो इधर नहीं चले जाएंगे, वो इधर नहीं चले जाएंगे. They're going to stay exactly wherever they are. So in this case, the dipoles cancel out, right? So remember, you get a lot of questions similar to this. I'll do another one. Let's do carbon dioxide. Now, carbon dioxide is a linear molecule. It's carbon bonded to 2 oxygens, right? So one oxygen, and it doesn't have a lone pair. So the shape of a carbon dioxide molecule is completely linear. Now, oxygen is the one that's more electronegative. So this oxygen, one of the oxygen on the right, is going to try and pull the electron towards the right. The other oxygen on the left is going to try and pull the electrons towards the left. Where would the electrons go? कहाँ जाएंगे?
Nowhere.
उधर ही, हाँ, मतलब वो इधर ही रहेंगे. They're going to stay right in the middle. They're not going to go either to the right or either to the left, because the 2 forces will get cancelled out. They will cancel themselves out. So again, it doesn't have dipoles. Dipoles cancel out in this case as well.
Sir?
हाँ.
सर ऑक्सीजन सारे लाइक कार्बन से इलेक्ट्रॉन मतलब इक्वली डिस्ट्रीब्यूटेड है
किस वाले में? इधर?
सर कार्बन
हाँ
डाइऑक्साइड में
हाँ, इसमें the electrons are evenly distributed, but they're not going to one side or to the other side. Clear? So
यस सर
so whatever the electrons are, they're evenly distributed. Because one oxygen is trying to pull the electron towards the right, the other oxygen is trying to do the exact opposite. It's trying to pull the electrons to the left, and the electrons are not going anywhere. ठीक है? अच्छा, अब ये कि let's do some more examples about shapes because you get a lot of questions on this. So let's talk about water का कर लेते हैं. So is water going to, नहीं, not water, ठीक है, water का थोड़ा सा मसला है, वो बाद में देखेंगे. We'll talk about let's say we talk about SF6, right? So that is octahedral. So that means S, it's got F on the right side. Octahedral means that 6 bonds, one on the right, one on the left. One would be on the top. One of them would be at the bottom. One of them would be behind sulfur on the Z-axis. And the other one would be coming out of the page in front of it. So you've got SF6, right? So will there be dipoles or not? Will it cancel out?
Cancel out.
Cancel out because all the fluorines, the top and bottom will cancel out. The one on the right and the one on the left, they're all trying to pull electrons, right? So their forces of attraction will cancel out. The one that's pulling it backwards, the one that's pulling it forwards, they would all cancel out. So dipoles cancel out. So polarity guess karna, you should know how to guess the polarity of a molecule. So let's say I have another molecule and it's got H. It's a tetrahedral carbon atom. And it's got F on one side, it's got hydrogens on the other side. Let's try and guess the overall dipole. Like, how would the molecule, which of the atoms out of all of them is the most electronegative atom?
So fluorine.
So what will happen is that fluorine is going to try and, so we're going to look at the overall polarity of this molecule. So all the electrons would kind of get pulled towards fluorine because fluorine is one of the most electronegative atoms. And there is no one canceling that. Like there is no dipole strong enough and doing it in the opposite direction because hydrogen is not very electronegative. So fluorine is pulling the electrons to one side. So this side of the molecule would be negative, and the rest of the sides of the molecules would all be positive because one of the atoms, well, we imagine one of the atom on one side is dragging all the electrons towards itself. So the entire electrons in the entire molecule are getting pulled towards one side. Is this clear? So it's going to have,
यहाँ पे dipoles cancel out होंगे
नहीं होंगे ना, क्योंकि कर ही नहीं ना, क्योंकि there's a very electronegative atom on one side and it's pulling all the electrons towards one side, right? And we can do more examples, like you have serial bond O and H. This is, and remember the shape has to be exact. You should know what the shape of the molecule is. So in this case, it's going to be fan shaped. इसमें बताओ, which side will have a negative charge? Which sides will have a positive charge? What's the overall effect?
The negative on O and positive on H.
So O would be negative because O is the most electronegative atoms out of all of them. So pure molecule ke electrons, they're going to get dragged towards the oxygen, and the other sides would then have a slight positive charge. So these are examples of dipoles not cancelling out. Now the other point is, when will you have a larger dipole? You're going to have a greater dipole if there is a larger difference in electronegativity, and again the dipoles don't cancel out. So dipoles can be smaller, they can be bigger. It depends on the electronegativity. So you're going to have bigger dipoles if the electronegativity difference is larger. And the condition is that they don't cancel out. So larger dipoles if there is a larger difference in electronegativity. Difference in electronegativity. Is this clear? Clear है?
सर
हाँ जी.
सर लार्ज डाइपोल्स कब होंगे?
जब ज्यादा डिफरेंस होगा इलेक्ट्रोनेगेटिविटी में. मतलब मैं एग्जांपल दे रहा हूँ ना कि let's say I have, what if you had iodine over here, either in place of fluorine. So if you had iodine, so what will happen? The dipole would be smaller, right? Because iodine is not that electronegative. So electron खींचेगा तो सही, but not that strongly. It's not going to pull the electron that strongly. ठीक है, is that clear?
Yes, sir.
So now the next one. The next one is you've got an extreme version of a dipole, and that's known as a hydrogen bond. So that is the second force of attraction, which is known as a hydrogen bond, or what happens in a hydrogen bond is it's simply the same concept, but it's an extreme version. I mean, technically you don't call it an extreme version of a dipole, but the concept is the same. Which means it's stronger compared to a permanent dipole. So this one is stronger compared to a permanent dipole. So what is a hydrogen bond? There are two conditions for a hydrogen bond. It's an extreme version of a permanent dipole. That means there's going to be a large difference in electronegativity. So there's supposed to be a large difference in electronegativity. And so it involves the most electronegative elements. It's either oxygen or nitrogen or hydrogen or fluorine, sorry. Oxygen, nitrogen, or fluorine, if they are directly bonded to H. That results in a very polar molecule. So that's the first thing. That's the first condition for a hydrogen bond to form. I'll give you an example that I have an HF molecule. The HF molecule is going to be very polar. The reason it's going to be a very polar molecule is that fluorine is extremely electronegative. So that means fluorine is going to have a very big negative charge and the H is going to have a very big positive charge. The polarity is going to be huge because the difference in electronegativity is very, very large. Is the first point clear?
Yes, sir.
So then the second point about the same thing is, so the second point about this is that lone pairs must be available. So lone pairs play a very important part. So lone pairs on oxygen, nitrogen, or fluorine must be present. So they must be present. So let's take that HF molecule again. So I told you that the HF molecule is going to be a highly polar molecule. It's going to have a very big negative charge and it's going to have a very big positive charge because the electrons are going to be very strongly attracted by fluorine. And there's going to be this other HF molecule, and that's going to be highly polar as well. So the two molecules are going to be really polar, but there's another reason why the polarity would increase, and the reason for that is lone pairs. Fluorine is a molecule that has a lot of lone pairs. Fluorine has 7 electrons, so only one of them is bonding. So there's only one that's bonding. So there are 6 electrons that are not bonding. So the fluorine atom is surrounded by a lot of electrons. Okay, so it's got lots of lone pairs. And the other fluorine atom, हाँ जी,
सर बॉन्ड पेयर के केस में क्या होगा?
मतलब क्या बॉन्ड पेयर?
लाइक बॉन्ड पेयर फैक्टर नहीं होगा ना इसमें?
नहीं, बॉन्ड तो फैक्टर ही है, मैं तो अभी इस पे फोकस कर रहा हूँ कि the fluorine atom has lots of lone pairs, ठीक है? So I'm just explaining why the attraction between two molecules is going to be that strong. The reason is, one of the factors is that the negative charge is really large and the positive charge is really large because of the large difference in electronegativity. So the positive side and the negative side are going to attract each other really, really strongly. Okay, so there's going to be this strong attraction between the HF molecules. But the more important reason is that the negative charge over here would also be bigger because there are lots of spare electrons around fluorine. So the spare electrons will increase the negative charge. So there are two reasons why the negative charge is so huge. One of the reasons is there's a huge polarity because fluorine is more electronegative. So these electrons over here are closer to fluorine. That results in a big negative charge. But another reason why the negative charge is much larger is because there are lots of lone pairs. So there are lots of electrons on this side of the molecule. So that is why the negative charge is also bigger. So the positive H is going to be attracted by these lone pairs. And there's going to be a very strong hydrogen bond that's going to be formed. So it's not going to be a weak attractive force, it's going to be a pretty strong attractive force. And that's your hydrogen bond. ठीक है
तो लोन पेयर क्या इफेक्ट करेगा?
हाँ,
लोन पेयर क्या इफेक्ट करेगा मतलब इधर?
देखो पहले भी था ना नेगेटिव चार्ज था ना, you had fluorine molecules, you had all these molecules that had dipoles, right? So one factor is that there's a dipole and the dipole is really large. Why is the dipole large? Because there's a large difference in electronegativity, ठीक है? जिसका मतलब है the negative charge is really large, the positive charge over here is really big, right? But one of the other factors why this negative charge is so large is कि यहाँ पे there's so many electrons that are not doing anything. What is the charge on those electrons? That's also negative, right? So that increases the negative charge even more. Clear path?
Yes.
सर सर तो हाइड्रोजन बॉन्ड्स की वजह से ज्यादा हो जाएगा ना इलेक्ट्रॉनिक जो हमारे पास डाइपोल थे वो काफी ज्यादा हो जाएंगे ना?
हाँ, तो basically वही है ना कि it's a dipole, but it's like an extreme version of a dipole. So the negative charge over here will attract the positive hydrogen very, very strongly because of two reasons. One of the reasons is that there's large polarity. The other reason is that there's so many electrons over here, okay, the negative charge becomes even bigger. So the attraction for the positive H of the other molecule, it increases. So hydrogen bonds are really strong. Okay, is this clear?
Yes, sir.
So this is hydrogen bonds. Remember two factors. That one of the factors is that it involves the most. So how do you figure out an atom has hydrogen bonds or a molecule has hydrogen bonds? You're going to look for oxygen, nitrogen, fluorine, which are directly bonded to H. And then you're going to look for, are the lone pairs available or not? So for example, I've got a water molecule. So if I have a water molecule, will it form hydrogen bonds or not? Now water molecule has a bent shape because it's got, so a water molecule will form hydrogen bonds because because one reason is that O is directly bonded to H. So that means it's a very, very polar bond. And this is the shape of the molecule. The other reason is the negative charge is also larger because oxygen has 2 lone pairs. So because of the presence of lone pairs, the negative charge is also much bigger. So 2 water molecules are going to attract each other with a lot of force. And so here's one water molecule, here's another water molecule. Now, when you're going to draw hydrogen bonds, remember this. Okay, put the negative charge, put the negative charge separately on these lone pairs. Over here as well. Don't write one big negative charge instead. Draw a negative charge on one lone pair, I mean, they're going to ask you to draw this. So make sure that you put negative charge on both lone pairs independently. And when they ask you to draw hydrogen bonds, 2 water molecules are only going to make one hydrogen bond between them because of the shape. Like this H is facing that lone pair, so they would attract each other. The other ones are facing, because of the shape, they're facing some other direction. So remember this, water molecules will only end up forming one hydrogen bond. The other ones will form hydrogen bonds with other water molecules, like there might be another water molecule, maybe somewhere else. Let me draw it. So there might be another water molecule. So this H over here will be attracted to the lone pair of the other water molecule. So that is hydrogen bonding, and which is why the attractive force between water molecules is really large. So is this point clear that this is hydrogen bonding? It's an extreme version of a permanent dipole, and it's a lot stronger compared to permanent dipoles. And you should know how to draw diagrams for this. So we're going to go into a lot more detail in the next class, and we'll do past paper questions on this. So first thing, you have permanent dipoles, and then you have this extreme version, which is known as hydrogen bonds. And hydrogen bonds are stronger compared to permanent dipoles, but hydrogen bonds are a special case. It just involves oxygen, nitrogen, and fluorine. They should be bonded to H, and the lone pairs, they must be available. Okay? So we'll, हाँ जी.
सर तो क्या डायपोल्स की डिफरेंट साइजेस हो सकती हैं?
तो वो तो हम डिस्कस कर चुके हैं ना कि डायपोल्स किसकी स्ट्रेंथ किस पे डिपेंड करता है. If you have a large difference in electronegativity, मतलब ज्यादा डिफरेंस होगा तो नेगेटिव चार्ज क्या होगा? It's going to be bigger. Positive charge would be bigger as well, right? Clear है?
यस सर, वो क्लियर हो गया.
जी सर, आप वाटर का बोल रहे थे कि मतलब उसमें सिंगल मतलब होगी, सिंगल आपने क्या अट्रैक्शन होगी, वो क्या मतलब
वो मैंने कहा था कि जब आप शो करते हो ना, they ask you to draw hydrogen bonds in water. ठीक है? So if they ask you to draw, make sure you draw just one hydrogen bond. Like because of the shape, this hydrogen is pointing in some other direction. So there's only one hydrogen that's pointing in the direction of the lone pair. So you're going to show a dotted line that shows hydrogen bonds forming between them, right? The other lone pair is pointing in some other direction. So it's not going to form a hydrogen bond with this one. Is that point clear? Like this hydrogen, this hydrogen is pointing in some other direction. So it will form a hydrogen bond with another water molecule. So remember this, people make the mistake that when they ask you to draw hydrogen bonds, so they just randomly just start connecting lines between them, right? So just make sure one of the positive H is going to attract just one of the lone pairs. Like this positive H will attract the lone pair of the other water molecule. So it's not, so between water molecules, there's always going to be just one hydrogen bond, because the other ones would be facing some other direction and they would be pointing in some other direction.
So sir, it will basically connect the lone pairs of oxygen.
हाँ, मतलब positive H gets attracted to the negative lone pairs of oxygen. ठीक है?
सर ऐसे तो नहीं हो सकता ना कि कोई लोन पेयर्स नहीं हो?
नहीं, हाइड्रोजन बॉन्डिंग के लिए लोन पेयर मस्ट है, क्योंकि हाइड्रोजन बॉन्डिंग इसलिए तो एक्सट्रीम हुई थी ना कि why was fluorine negative charge so large? Because lone pairs contributed to the negative charge. ठीक है?
So मतलब डायपोल के लिए ये बात इंपॉर्टेंट है?
नहीं, डायपोल के लिए इंपॉर्टेंट नहीं है. डायपोल तो किसी में भी बन सकता है, लेकिन ये जो extreme version of a dipole है ना, which is hydrogen bond, that can only form if the most electronegative element is involved, like fluorine, oxygen, or nitrogen, that is directly bonded to H, resulting in a very polar molecule. Plus, the lone pairs should also be available. That will increase the negative charge even more. which is why the attraction would become really strong. ठीक है, तो ये दोनों चीजें होनी चाहिए for hydrogen
Sir?
bond. हाँ जी,
सर इस तरह से हो सकता है कि लाइक कोई टेम्परेरी डायपोल है या इंस्टेंट डायपोल है इस तरीके से?
नहीं उस पे वो तो हमने किया ही नहीं अभी.
ओके सर.
ठीक है, ये जितने भी पढ़े हाइड्रोजन बॉन्डिंग एंड दीज आर परमानेंट डायपोल्स, like fluorine would always be negative, ठीक है, and hydrogen would always be positive because fluorine is always more electronegative. ठीक है, चलिए ठीक है, नेक्स्ट क्लास में इसका वो कंप्लीट करते हैं. we'll do past papers on this. ठीक है, remember this is important, this one is important. ठीक है, चलिए, okay everyone,
ओके सर.
love